Okay, here we are. So another Friday Spry play. This time I'm going to go through the new Point3D calculated fields, have a quick chat about a couple of ideas on how you can use them. So what we're talking about is the new ability in your field setup to be able to turn a Point3D type into a calculated field. Now I'm not going to touch my existing calculated fields on this one. I'm going to create a couple of new ones. So even though these are flagged as calculated, previously what they've been, or what they will continue to be at their bases, will be these are generated from the Centroid calculator. Now this has some limitations in that it's based purely on the Centroid. Obviously, that's what the Centroid calculator does. But that you can't easily sort of tell it, oh look, I'm happy with this component but not that component, or I want to round it, or I want to do this, or I want to do that. So I'm going to show you a couple of examples of how you can use them, and if you've got questions about other ideas you have on how you want to use them, you can let us know. So right now we have these calculated roof and floor coal centroids, and in my model I have a waste and coal floor centroid being used. Now there's a couple of different limitations of this. Firstly, the solid that you have doesn't necessarily cover off all of the bench that you're at, and you might just want to say, look, when I'm at bench 80, my RL is 80. When I'm at bench 85, my RL is 85 in terms of haulage. So the first thing I'm going to show you is how you can convert an existing Point3D field and change its Z level. So we're going to go in and create a new series of centroids. So I'm going to call this one RL Centroid, and I'm going to turn it on to calculated. So if there was any data in there, changing it to a calculated field will clear it out. And in particular, in order to generate a new centroid as a new generate a new Point3D type, the new function that you want is called Point3D. It takes three values. It takes the X, the Y, and the Z, which is not made clear in the description, which we'll need to fix, but that's what it's asking for. So what we can do then is we can get the value from the floor centroid. So right now, what we have is there's a waste centroid here. So there's a couple of things that we need to do. Firstly, if there's no centroid there, we don't want to continue with this. So we're only going to do this if the floor centroid is not null. So we're going to start with a null check. And so what we're going to do is look for the floor centroid of the waste, and we're going to do a quick is null check. And we're going to put a not is null. So if not is null, and so what we're going to do here is we're going to go, if it's not null, then what we're going to do is we're going to put in our adjusted centroid. So you can go if is null, and we can put in an empty Point3D effectively. Now an empty Point3D in this system is going to look like a 0, 0, 0, which is not technically empty, but it's close enough for the purposes of this. So we can just go Point3D 0, 0, 0, 0, 3 zeros. So if it's null, don't bother trying to write something, it's not going to work. The next thing we can do is we say, okay, but if it's not null, then we're going to grab some information from it. So there's a few functions in here, get X, get Y, get Z. So we're going to use those. We're going to feed in the X from the centroid. Let's try this again. This is getting it. Here we go. So get X coordinate. We'll replace that one with the X. We'll do the same with, oh, that's an annoying bug. We'll do the same with Y. And then finally what we want is a number, but we want it based on the bench. So in our model, benches are always numbers. You may need to add additional checks if your benches are not always numbers for what I'm about to write, because what I'm about to write in here assumes that this is always something that can be easily, with no manipulation, converted into a number. Okay, so the way to do that is firstly we need to grab the bench, but the bench is not a string, it's kind of its own object. It doesn't have the type that we need. Without getting into too much detail, the first thing we need to do is convert the bench into text. That turns it into its name, so 80, 90, but as a string. The next thing we need to do is another one of these C functions, but this time what we're going to do is we're going to convert it into a number. So we're going to do C int, and then we're going to close that off. Even though there's another one here called C float, you can use that too. If you've got decimal places somehow in your conversion, now my benches, it's not going to make sense, but you may want to use C float. That's going to give you the option to allow decimal places. If you try to do C int on a piece of text that says 7.5, that won't work. So in here now, after all of that, firstly what we've got, and we'll change the layout of the function a little bit to make it a little easier to read. So if it's null, empty point3D. If it's not null, give me the X, the Y, but then create a new one based on the text of the bench. So we hit accept, we hit apply, and if we jump in and have a look at the table now, so we'll pick, doesn't really matter what record as long as there's some waste there. So in this model, it's anything up in the D seam should be fine. So it probably doesn't help that most of the records around here are probably pretty, we might head right on down to the bottom to see a difference. Here we go. So these ones here. So at the 80 and the 75, where the floor centroids are actually, you know, the solids themselves don't go all the way down to 75. You can see these ones here are exactly the same centroid otherwise. The formatting string is ever so slightly different, but the numbers themselves are the same. And then we've got 81.2 here and 80 here. So that one there is going to give us, and that if there's no, if there's nothing there at all, like if there's no, give me an example where there's nothing, probably down in the F, right down the bottom. Yeah, so you can see we've got a point3D that's got 0, 0, 0 in it. This is a slight difference to not having a centroid at all. So that potentially there's some things, if you're checking for null centroids, this is no longer a null centroid. It's a centroid with a 0 coordinate. So potentially, depending on what you're doing, that can be a tiny bit trickier. We may add the option to create a null centroid in the future, but it's not currently there. So that's option number one. That's hard coding an RL, and that just allows you to then have your haulage come off of that hard RL. That's one way of doing it. That's one option. The other thing that I was going to show you today is a way to avoid having to run the centroid calculator twice. So right now, if you've got a model where waste turns into coal turns into waste due to loss and dilution and other issues to do with high ash coal or whatever it is that converts a material from its original type into a different material type that maybe has a different type of solid. Previously, what you've had to do is run the centroid calculator more than once, which is a little error prone and does trip people up occasionally. So the system that we can set up now is we can add some new fields and we can essentially summarize the fields together. Now this one, it depends on how important you place the difference between two solids that might share the same record, but for my purposes I'm just going to have a single centroid for scheduling. If my waste and my coal are both there, the centroid, the floor centroid of them is going to be very, very similar for my example, so I'm just going to have one centroid and I'm just going to call this my scheduling centroid. For the purposes of helping somebody else understand it, if there's waste, waste, if coal, coal, if not, 0. So we're going to create something here where we do a null check for waste, and if it's not null, we'll do waste. If there's coal, alternatively, we're going to use coal, and if there's nothing there, we're going to use, actually, we don't even need to do the if coal check. I haven't done this yet. I'm going through the demo as I often do with these, as I just do it for the first time live. But what we're going to do is we're going to do the first check, and we can steal it from the other check that we did. So the first part of the check is relating to if it's null or not. So to help me out, I'm just going to go and grab that. And I'm going to change this one. I'm going to say if it's not null. So you may have seen the exclamation mark that is also valid. The exclamation mark and the word not mean the same thing. I prefer to use not. It's a little bit easier to read. So if it's not null, which is a tiny bit tricky, but if it's not null, what I want to do is I just want to get the value of the floor centroid. So I'm just going to use waste. If there's waste, I'm going to use waste. So I'm just going to go if waste, give me waste. All right, so that's the first component. That's the if the condition is true, return this. And then the second condition, what I'm going to do is I'm just going to return the coal centroid. If the coal centroid is null, it's going to return null, but it means both of them are null, so I don't have anything I can really base it off of. you can have a third option which gives you like a default that might help you out. It's really up to you. You can use if statements to do multiple condition checks. But this one here just says, if it's not null, give me the waste. If it is null, give me the coal. If the coal is also null, it's going to end up null. I'll show you what that will look like by breaking my model a little bit. But that one there now, my scheduling centroid, means I only have to run the centroid calculator once. And what it's going to do is it's going to force the waste down the chain, assuming that the waste is there. You might want to refer to coal first. Maybe coal is more helpful for you. Look, these things are going to be so close to each other in most models that it doesn't really matter as long as your Zs are in roughly the same space. If you've got a model that's not benched, this may not be acceptable. What you may need to do is generate two scheduling centroids. So one that says waste scheduling centroid that does waste first, then coal, and then vice versa. So you may need two centroids, or three or four, or how many types of solids that you have. So what I'm doing here is one simplified centroid. If your model is not benched, you may need to have two centroids regardless. If that's not clear, if you're not sure what this is doing, you can give us a buzz, ask us the question. But the purpose of this and the benefit of this is now when I regenerate my centroids, I only have to do it once. So I go utilities, centroid calculator. When I set my waste floor to waste floor, my coal floor to coal floor, I regenerate that. If for some reason my coal has become waste or my waste has become 100% coal, I'm going to be able to grab the centroid from the alternative field in this sort of aggregated field. And so the last thing I would need to do is change my centroid field to the scheduling centroid field. So we'll go and grab that. I mean, this is pretty specifically helpful for preventing mistakes from being made in the haulage space, because sometimes what happens is if you're only using centroids for haulage and you're not really paying close attention to some of this stuff, it can mean that you end up not getting haulage results from a model if it's not been set up well. So using these is just part of the process of having a model that's set up to prevent to try and minimize user error, manual handling errors, things like that. If you have any questions about that, feel free to ask. We've just added this functionality, and like most functions in this stuff, we don't realize its full potential until until it gets used a little bit more. Potentially, there's some there's some more complex or more interesting ways of using it. If you come up with a good way of using it, please let us know. We'd love to know what you're doing with this stuff. Otherwise, thank you once again, as always, for your attention. Have a great weekend.